Hello guys, I feel obligated to mention the MVC architecture of Zen Framework 2. Actually, there is a brilliant webinar done by Enrico from the Zen Framework team. So I just built a mind map based on his webinar, and I'm gonna attract your attention to only certain points. So the new architecture in the Zen Framework 2, we were already talking about the dependency injections. I mentioned the event manager, so let's look how this is implemented in Zen Framework 2. Not all of these concepts, but some of them. So the new architecture includes the MVC, dependency injection, event manager, service manager, module manager, following the PSR2 compliant structure. What I mean by that, when you go to modules, application, source, here this application is standard PSR2. The view and the application, all this file structure in the modules is a standard already in PHP. Packaging system which is used in Zen Framework 2 Pirates and Composer. As I said, Enrique Samuel has a brilliant webinar, and you can find the link to this webinar here in the mind map. You can watch it. Here it is, the URL. If you want to learn about the MVC Zen, go there and just look for the details, watch the webinar. Okay, so I put it here PHP 5.3.5 because the current version of Zen Framework 2.1, in the mail list a lot of developers report that Zen Framework 2.1 works with PHP 5.3.5. I'm not sure about that. I will check it again. Performance improvements, they're coming from lazy loading. It's a design pattern. The lazy loading is a design pattern. The new core of Zen Framework 2 is aspect-oriented design and dependency injection, and here it is, the drawing of the MVC. This is how everything is done. So the user communicates with the controller manipulates the model, and changes get reflected in the view, and the user sees the changes. If you have such architecture in your application, the application could be highly decoupled, and this is a very good potential for easy change of the application and flexibility, and a very good platform to extend your application if it's built around this design pattern. Martin Fowler mentions the MVC as a design pattern, and many authors I read think for the MVC as a principle, basic principle or paradigm: separation of concern and code reuse. This is the result of using the MVC, which are good things, separation of concern. So how the Zen Framework 2 works: everything is event driven. Let me show you that. So this slide actually is taken from Enrico's presentation. I have to give him a credit. So HTTP request, bootstrap, all listeners get notified about the bootstrap process in different points after that route, where we actually tokenize the input, the URL, and we are making decisions which controller to be called, which module, and dispatch, where we instantiate the controllers and do the job, and at the end the response. This is the life cycle of the application written on Zen Framework 2. Yeah, here it is, the explanation tries to find out which controller to run, and dispatch controller gets loaded and executed. A common workflow, this is a code. So 2 times use, just not to write the full path to the classes. Service, new service manager, service config. This is the configuration array. Application, new application, configuration of the application, and we inject the services, the service manager in the application. Application bootstrap, after that, where the configuration takes place. Application run, response, and finally we send the response to the browser of the user. This is the main workflow. Default services. When we inject the services into the application, here, the application expects some of the services to be already there, instantiated. So what are the default services? Let me see this. Application expects the service manager configured with the following services. Yeah. Event manager, module manager, request, response, root listener, router, dispatch listener, view manager. All these services, objects, they're not simple objects, of course. Some of them, of course, they're complex objects, should be instantiated and ready when we inject the service manager, the instance of the service manager, into the application. And now we can look at the file structure of the skeleton application, of Zen Framework skeleton application, because so far I just showed it to you how to build a skeleton application different ways in the cloud IDEs, but we didn't discuss, and also in the portable devices, but we didn't discuss the structure. We didn't explain almost anything. Before we do that, I just want to attract your attention on something which I find super important. Even if we don't look at the structure of the application, is not such a big deal, but I have to attract your attention on the fact that the Zen Service Manager is a service locator implementation. In previous lections I was talking about the dependency injection and service locator patterns as a way actually to practice the inversion of control. And this is very important to understand that the service manager in Zen Framework 2 is actually the service locator design pattern implementation, which means that it plays the role of the repository. Let me just try to recall the most important thing and share with you. So the service locator is a different thing, is not like a dependency injection. Dependency injection container, it's a fundament for the service locator, but the service locator is slightly different. From the point of view of the developer, the service locator and the object, the service locator it looks like a repository from which you take different services, different objects, and you inject them into your application. So there is a dependence of each one of the consumers from the service locator. Each one of the classes objects, when gets instantiated, should get an instance of the service locator. Okay, this is the most important. What is a service locator? Well-known object in which you can register object and retrieve them later. And another important thing actually, which comes from the article of Martin Fowler, is that this service locator is driven by the configuration, because there are other way to drive the service locator, by coding. If there is too much conditional logic when we create objects in the service locator, we should be moving not to configuration files but using a language tools to do that. But in this case, in Zen Framework 2, actually we use a configuration. The service locator is driven by the configuration. The type of services, this is also very important, so that's why I want to attract your attention on that. Explicit. In the configuration file, we can say name and object. We can give directly an object, and the service manager will keep the name pair and the object. Invocables, so we don't have to give to the service manager object, instantiated object. The service manager knows how to instantiate the object, so we can give him a name and a class to instantiate with full namespace. Uses lazy loading, which means that the class doesn't get instantiated. It doesn't get converted immediately into an instance of this class. It's gonna be instantiated when it's necessary, if it's used somewhere in the code. Factories, those are callbacks, callable returning objects. Aliases, so we can use one name and point with an alias to the same object. Abstract factories, unknown services. Scope containers limit what can be created and shared or not, you decide. Let me see what else I think it's very important and I want to attract your attention. I just want to be sure that my students know all these concepts and all these things, even though, as I said, there are a lot of sources in internet where you can read. Enrico Samuel is one of them, Martin Fowler, and many others. So Matthew as well from the team, Zen Framework team, also is writing about these things and these topics. There are webinars, there is a documentation. I just want to attract your attention on that, as I said. So that's it for now. I just want to go through very quickly through the structure of one application. Let me follow again the same pattern. Let's look at the config, application config, which is the main configuration file of the application. Let's open it here and see how it looks. As you can see here, we have a module part where we describe all the modules in the application. Module listener options. Here we are configuring the global paths, that's the outloader, and the module paths. Even the vendor is included here, so even the vendors are treated as modules. Public htaccess, it helps actually for the front controller design pattern in the public folder. Let me show the invisible files, hidden files. Okay, so it is in the public folder, htaccess. In fact, all the requests get redirected to the index.php. That's all what the htaccess does. Public index.php, and makes, of course, the URLs human friendly with the slashes. This is what this code does, and it's for Apache web server. It's not for us, for the developers. Of course, it's important. It concerns us as well. Index. Index is extremely simple. First, we change the folder the directory, to the root of the application, include the autoloader, and after that, very simple, we use a static method in it just to make it simple. Include the configuration file of the application and run the application. That's all we do. So let's look at other important files. Modules. The purpose for the module is to inform the AVC about the service and event listeners. Subset of the applications. They are subset of the application. Modules are simply a namespace containing single class file module. So in the simplest form, the module is a namespace and only one file. That's it. So let's look at the application module as an example. This file is only necessary when we register the module in the config file. Only this file is absolutely required. And only the class, namespace application, class, and only this method. The rest is not obligatory. Let me zoom it so it's better seen. Okay, here it is, one example of module PHP. This is the simplest form of module. We have to have one class file called module and only one method inside getConfig, which returns actually the module config PHP. Let's look at the module config PHP as well. It's a little bit more complicated, but it's very simple in fact. Of course, for the configuration files we could use ini files or YAML or whatever, but the fastest way to do that, to configure your application and the module, of course, is to use the PHP arrays, because we don't need to do any extra steps. And as you can see, all it contains in fact is the root. From Zen Framework 1 we already know very well the roots. This is the default root. After that we mimic again the behavior of the Zen Framework 1 with the slashes, so we don't have to explicitly define more roots if we add controllers to the default application in the skeleton application. All this part from line 54 up to the top to line 1 is about routing. After that is the service manager section, because we want application. This is how we do it, and we send options about how the translation should be done. We use getText here, and we say in which folder, of course, are the translation files. This section is about the controller, where the controller is, and the last section is about the view manager. As you can see, here we define the doc type HTML5, which can be seen when we run the application. Not found template, error template, where the layout of this module is, and again the paths to error 404 and the error. That's it. This is about the module configuration file. It's clear. And finally, the controller. We very well know the structure of the controller. Again, we have the very well known pattern of naming. Here it is, the controllers, index, controller, and the pattern for naming the methods, actions inside. Let's look at this here. Application module controller. Here it is. All this this controller does actually is returns a new view model. That's it, because we don't have parameters to send to the view, and the rest is done in the view. Here it is, the view, and as we can see from the configuration file, this is the layout. This is another design pattern, 2 steps view, layout, and application. Each controller has a folder called by after his name, index in this case, and each action has a related view. Again, the same naming convention, index PHTML. That's it for now. I'm not gonna waste your time describing more obvious things. See you the next time. Bye for now.